everybody, this is Alex Merced from alexmercedcoder.com, and in this video we're going to be continuing our lessons on Java. Okay, just a couple little footnotes from the previous video. Okay, so you might remember that I kept getting this sort of linting issue, like basically it would just say when I tried to define a package, it would complain that I was defining a package. Or it would complain if I didn't, but it wouldn't compile and vice versa. Okay, so just to give you some clarification on how to avoid that is you generally want to be open to the directory in VS Code that you're going to be working in, because it's going to assume that whatever directory you're opening in is sort of the main scope of your files, and anything below that is a package. So in that case right here, my main folder here has my main.java, and I don't need to define a package here because I'm at the top level. Okay, and then I would define a package if we're in a subfolder and whatnot. But yeah. So again, here I have my main Java file, and then here I have my other Java file, which was just me playing around. But we're going to do is focus on control flow today. So basically, structures that allow you to control the flow of your program, whether that is looping, if statements, etc. So first we'll do if statements. So an if statement, again, and if you've learned any other programming language, you're probably fairly familiar with this. But an if statement just says, if this thing is true, then run this code. So we'll just say, hey, if the number 5 equals, and notice I'm using two equal signs because I'm not saying this should equal this. I'm saying, does this equal this? So there's a difference. When I use two equal signs, I'm asking a question. When I use one equal sign, I'm taking an action. I'm saying the thing on the left is now going to be valued based on the thing on the right. So instead I'm saying, hey, is the thing on the left the same thing as the thing on the right? Like, I'm asking a question, is that true or false? So if 5 equals 5, then whatever code should run here. And now see, it's complaining because they're identical expressions. I'm saying is the same thing equaling the same thing, which is kind of a silly thing to ask. But just to satiate the IDE overlords, what I'll do is I'll create a variable. So we'll use var, and we'll say var x equals 5. Okay. And then we'll say, does x equal 5? And if that's true, if this variable x equals 5, then the code in here will run. And we'll just say system.out.println, and we'll say the number is 5. And then I can include an else statement, which would run code if it's not true. So I can be like system.out.println, and then say the number is not 5. Okay, so there is the code. Now I'm going to just make sure that I run this using Java. Again, I'm using Java 17 as my command, because under the Java namespace I have Java 11 currently installed. So for you, if you install Java 17 from the get-go, or you use something like Corsair to manage your versions of Java, you're probably fine just writing Java. I had to create a custom alias that pointed to the Java 17 executable, so you don't necessarily have to write Java 17. If you have Java 17 installed properly, you could just write Java and Java C for the compiler. Okay, for me, because of the aliases I created, it's Java 17 and then Java 17 compiler, or I think Java 17 compile if I'm doing the compiler. Okay, so Java 17, and I'm going to be running this file, main.java. And see, it says the number is 5, because this is 5. Now, if I made this anything other than 5, let's try to run the file again. The number is not 5. So you see, when it was 5, this expression evaluated as true, so this code ran. And when this was not true, this code ran. So that's all an if statement does. But again, an if statement can then allow our code to handle a lot more unique situations. Now for a loop, there's your traditional while loop. So the way you would do this is you would sit there and you would create a variable. So we'll say, I'll say int counter equals 0, just to kind of show different ways of declaring these variables. So here I'm using the type method where I declare the variable by declaring a type and saying, hey, this is an integer. A counter is an integer, and I'm going to assign it the value of 0, which is an integer. And then we do while, and then again, just like the if statement, in the while we put what the expression we want to evaluate. And long as the expression is true, so whatever we put in the parentheses is true, then this code will run over and over and over again. So I'm going to say long as the counter is less than 10. Then run this code. So we'll say system.out.println, and what I will do is pass it counter. So we'll log counter. And then after doing that, we will then, system.out.println, we want to make sure that we add 1 to counter. So we'll do counter plus equals 1. Now whenever you see the plus equals, counter, there we go. And then semicolon. Okay, but what the plus equals means, it means take the thing on the left, add the thing on the right. So that's the plus part. And then take whatever that result is and then assign it to the variable. So if the counter was 0, I'm going to add 1 to it, which is 1, and then now counter equals 1. Okay, so I could do plus equals 2, plus equals 3, however you want to, whatever you want to add. That also works with minus equals, multiply equals, these compound math operators. Okay, so now if I do this, what's going to happen is that the very first time this runs, counter is 0. So counter is less than 10, so the code runs, but then after that, counter is now 1. So it loops again, then 2, then 3, then 4, then 5, until it gets to 10. So let's see if that works. See 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, in Java, we have another way of doing a loop. Okay, that's essentially the same thing. Like we could essentially the same pattern, but notice how I had to define the counter in one line. I had to define the true expression here, and then increment it here. Well, I could do that all sort of in one fell swoop by using a traditional for loop, where first I would declare the counter. So we'll say this time I'll just do count. Int count equals 0. Then I would say counter is less than 10. Count is less than 10. And then we'll say count plus equals 1. And then we would do the curly brackets. And essentially, this is doing the same thing that this is doing. This is me declaring the variable like I did here. This is the expression that this loop will run when it's true, just like here. And then this is me incrementing the counter like I did here. But instead I can just do it all in one line. It's a little bit more compact. Okay, and now I can do something like system.out.println and say counter. Okay. Okay, counter, oh no, count, it's gotta be count. And there we go. Now I should see 2 loops now. So if I run this now, see loop 1 through 9 and then loop 1 through 9 again, because these are both doing the same thing, just slightly, can be a slightly more succinct syntax. They can both be useful in different situations. Like if I'm just like looping over an array, or I'm looping, doing like a loop like this, I would just loop this. But sometimes I just want a straight up infinite loop. You know, like I'll use infinite loops for a game and then use a break statement. So I might do something like this. I'll just say true. Okay, so that means just keep looping long as true is true, which is going to be always. So that's an infinite loop. It'll always loop. But what I'll do instead is that at the end of each count, I'll say if counter equals 5, break. And what that'll do is break the loop. Okay, so basically I'm still, and this is what I would do for like a game. I would sit there and say, hey, when the chooser chooses to quit the game, then break the loop. And then that would just be the end of the game. So if I run this, And see, even though this is technically an infinite loop, by setting it to true, as long as I use the keyword break somewhere to break the loop eventually, I end up in the same place. So those are different like control flow structures. You also have a switch statement. And you have switch expressions right now, which are, I think, in preview. So we'll probably do a separate video on that. But in this case, we can do like a switch. So a switch, okay. And the way a switch statement works is that you would say, hey, I want to check something here. So I want to check counter. And I want to say, hey, if counter equals 0, so case 0, so you're checking against different possibilities. So it's not whether like the thing here is true or false. You're saying, hey, I want to check this thing against different possibilities, and each case is a different possibility. And I can say like, then below case, I can be like system.out.println and say the number is 0. Okay. And then I can have a default case and write system.out.println the number is not 0 because it's something other than 1. This is useful if you have like a lot of different possibilities. Like I have a different situation, like again for a game where I might have them push like Q for quit, A for attack, so then I can check, hey, which button, check it against different like possible button pushes. That's just another way to kind of handle this. So I sit there and I run this. Oh, the extra parentheses right here. And see, it says the number is 0. And then again, if I change this to 1, the number is not 0. Nice. So that is the story there. And hopefully that gave you a nice additional taste of Java. I'll see you guys in the next video, but have a great day and enjoy as we use Java 17, the current sort of long-term support, newest long-term support version of Java. Thank you.